Hi everyone, here we have a question on vector diagrams. We have two questions. The first one, given that the vector OP is equal to 2i plus j and the OQ is equal to 5 minus 3j, find the magnitude of PQ. How do we do that? Let's start by collecting our information given in the question. We are given the vector OP as 2i plus j and the vector OQ 5i minus 3j. Now we want to get the magnitude of the vector PQ. Now the magnitude of the vector PQ will be the magnitude of the vector OQ minus OP. That magnitude. This is equal to, we know OQ, that is OQ 5i minus 3j minus OP 2i plus j, that magnitude. Alright, so when we're subtracting a vector from another vector, right, I component go with I component. So we say 5i minus 2i. So we just write that as 5 minus 2, and then I is outside. Plus, we must use plus this time around, and then we do the same subtraction with the j component. The j component here is negative 3. So we say negative 3 minus 1. The coefficient here is 1. Then we say j. Now this gives us the magnitude 5 minus 2 is 3i plus negative 3 minus 1, negative 4j. This is magnitude 3i plus minus 4j. And we all know that the working out of magnitude is taking the square root of the squares of the squares of the two components. Alright, we square the two components. Now this gives us the root of 3 squared is 9. The root of negative 4 squared, pay attention, negative 4 squared is not the same as negative 4 squared. They are all pronounced the same. Negative 4 squared, negative 4 squared. But this is not the same as that. Alright, so you have to take note. Many students write this in the place of this. What we are asked to do here is this one and not that one. Now let us see. This one here, the square has to affect the negative and the 4. So this will be negative 4 multiplied to negative 4. But you can see that it's not the same here. Here the square affects only 4 and the negative is outside. So the negative is outside and we square 4. So you can see negative multiplied to negative, positive. 4 multiplied to 4, 16. And that is not the same as negative 16. So we should be careful. This is the one we are asked to write and not this one. Okay, that aside, we now have here plus 16. This gives us the root of 25, which is simply 5 units. Thus, the magnitude PQ is 5 units. That does it for the first question. Now, let's look at the second question. The second question is based on this vector diagram. You see, the figure shows the diagram of the vector diagram such that OA has carrier vector small a, OB has carrier vector small b, and the ratio AX is to XB is 1 is to 3. Expressed in terms of small a and small b, the vectors AB, OX, and XB. We're going to work using this vector diagram. Number 2. Let's collect our information just like we did with question 1. We have the carrier vector for OA as A, carrier vector for OB as B. And the next information, we are told that this proportion Alright? We're given this proportion that AX is to XB is 1:3. Alright? Now, express in terms of A and B the vectors. Let's start. The vector AB. Alright? Now, AB, we already have our elements here, so we don't need to do any vector analysis. So, AB will just be OB minus OA. This is simply the carrier vector small b minus the carrier vector small a. As simple as that. Now, what is OX? Now, OX, we don't have OX in our main. OX, there's no carrier vector for OX. These are the only vectors with carrier. These are only vectors with carrier vectors. So we have to work out in such a way that we will express this OX in terms of OB, and OA. So that we can use the carrier vector. Remember, we're asked to express in terms of small a and small b. Now, what is OX? We now go to the diagram. Look at the diagram. OX. OX again means you are at O and you're getting to X. Look at the arrow. You are at O and you're getting to X. You are at O and you're getting to X. You see, there is no carrier vector that moves directly from O to X. We can either move this way thanks to this carrier vector, or move this way thanks to this carrier vector. So you are here. Here where you are. How do you get to X? You can either move OA and then AX. Alright? Someone might be asking, there's no arrow here, but we know AB. We've calculated AB earlier on. In terms of those carrier vectors, we know AB. Alright? So we can move OA, AX. That will have helped us to move OX, geometrically speaking. Or we can move OB, BX. Again, geometrically speaking, we'll move OX. So we're going to solve using the two roots, and we'll realize that we'll have the same expression. Alright, so we'll say OX, starting from O getting to X, is either you move O to OA, O to A, and A to X. Or you move O to B, and then B to X. Either way will give us the same result, whichever of the two that you choose. Alright, let us start. OA, there is already a carrier vector, is A. Now, AX, from A to X, from A to X, we will now have to make a recourse to this information. You see, AX is to XB is 1:3. How do we interpret this? AX is to XB is 1:3. That simply means that AX is one part of AB. We look at the extremes. The extreme left, extreme right. The whole line is AB. That's the line AB. So AX is one part of AB. And XB is three parts of the same AB. Three parts. That means this is one. Then we just divide this into three equal parts. So that AX is 1, 2, 3 parts of AB. So altogether, what is AB? How many parts have we had for AB? We have 1, 2, 3, 4 parts. Alright? So that analysis now helps us to further our work. So we're going to say therefore that AX is 1 out of 4, because we now have 1, 2, 3, 4. So it is 1 out of 4 of AB. Okay? Again, the direction is very, very important. We're working with vectors. Direction is very, very important. AB is not the same as BA. You should be very, very careful. Okay. So this simply means we have A plus 1/4. AB, we already had AB earlier on. AB is simply B minus A. So this gives us A plus 1/4 B minus 1/4 A. This is A minus 1/4 A plus 1/4 B, which is 1 minus 1/4 is 3/4. So we have 3/4 A plus 1/4 B. So this is the expression for OX. Now, if you had chosen this other route, this movement, this displacement, right? OB, again, we have the carrier vector OB. This will just be small b plus bx. Now, look at bx. Bx is 1, 2, 3 parts of BA. Pay attention, we're moving now this way. It's no more AB, it is this way. So it is BA. So Bx is 1, 2, 3 parts of BA. BA is 1, 2, 3, 4 parts. So we're going to have 3 out of 4 of BA. Very, very important. All right, so this gives us B plus 3 all over 4. BA now, we all know from vector analysis, is that it's negative AB. All right, BA is opposite direction to AB. AB is like that, BA is like that. So when they are opposite but equal in magnitude, we just put the minus sign. Now this gives us B plus, open another bracket, plus minus becomes negative. No, pay attention, plus 3 all over 4. You have negative, put the negative there, plus minus negative into AB. This is AB again, B minus A. So have B minus A. And this gives us B, open another bracket, negative 3/4 B, negative, negative, positive 3/4 A. Now, B minus 3/4 B is simply 1/4 B. So we have, look at it, 1 minus 3/4. We can just make this one also a fraction. LCM is 4. 4 divided by 1 is 4 times 1 is 4. All right, 4 divided by 4 is 1 times 3 is 3. So we have 1/4. All right, so we have 1/4 B plus 3/4 A. Now, look at this result and look at this. You see 3/4 A, 3/4 A, 1/4 B, 1/4 B. So we end up having the same result. That is it for B. Now, what about C? What about C? We need some space. What about C? Now, let's look at C. C says we should get XB. The vector XB. Now, XB. XB is in the direction AB. They are in the same direction. XB, AB. Now, again, when we look at that proportion, remember a proportion is an expression that has two ratios. When we look at that proportion, we see that XB is 3 parts of AB. All right? So XB is just 3 out of 4. AB is 4. 1, 2, 3, 4. XB is 3 out of 4 of AB. As simple as that. So this gives us 3 all over 4. We already found AB. AB is small b minus A. And that's just all about XB. Alright, we have succeeded to express XB in terms of small a and small b, just like all the other ones. Thank you.